Hello everyone, welcome back to my channel Sarada Devi Maths Classes. Questions from 12 onwards in exercise 9b triangles. 12th question is, in a triangle ABC, AB is equal to AC. AD is perpendicular to the side BC and CE is perpendicular to the side AB. Then we have to prove that AD is equal to CE, that is AD and CE. We have to prove that these two are equal. We can take two triangles ADB and CEB. We can pull it out and draw it separately. ADB like this, CEB. Here in the case of these two triangles, we can mention some points. So we can write first point as in triangle ADB and triangle CEB. AB is equal to BC. It is given this side and this side BC. So we can write the second point as AB is equal to BC. Reason is given. Then what about these two angles? One and the same B. So we can write third point as angle B is equal to angle B, that is common angle. Then fourth point, here these are perpendiculars. This CE is perpendicular to AB and AD is perpendicular to BC. So we can mark this as 90 degrees. So angle D is equal to angle E, that is angle D is equal to angle E, that is given each 90 degree. AB is equal to BC, angle B is equal to angle B common angle, angle D is equal to angle E. So two angles and one side. So we can say that triangle ADB and triangle CEB are congruent to each other by AAS test. So fifth point, therefore triangle ADB is congruent to triangle CEB by AAS test. Now what we have to prove? We have to prove that AD is equal to CE. Here AD is this side and CE is this side. So I have marked with a different color. This AD and CE are corresponding sides of these two congruent triangles. So we can say that this AD is equal to CE by CPC TC. So we can write a sixth point. Therefore, AD is equal to CE by what reason? CPC TC. 13th question is, PQRS is a parallelogram. L and M are points on PQ and SR respectively such that PL is equal to MR. Then we have to prove that LM and QS bisects each other. So L and M are points on this PQ and SR respectively. If O is the point of intersection of this LM and SQ, in order to prove that LM and QS bisects each other, we need to prove that LO is equal to OM and SO is equal to OQ. In a parallelogram, opposite sides are parallel and are of the same length also. That is, this PS and QR are parallel and at the same time they are of equal length. Again, this PQ and SR, these two sides are parallel and are of same length. That's the property of parallelogram. So we can come to the question. SQ and ML meet each other at the point O. So we can write that SQ and ML meet each other at the point O. Then we can write this as first point. Second point, PQ is equal to SR. PQ, that is equal to SR. What is the reason? PQRS is a parallelogram. Third point is, now splitting this PQ and SR, we can write PQ as PL plus LQ. We can write this SR as SM plus MR. So we can write third point as PL plus LQ, this PQ. That is equal to SR, that is SM plus MR. But we know that this PL is equal to MR. We can write this again as PL, that is equal to MR. So we can write that PL as MR plus LQ, that is equal to SM plus MR. What is the reason? PL is equal to MR, that is given. Here we can write splitting PQ and SR. This MR and this MR we can cancel. So what is remaining? LQ is equal to SM. Now let us take triangles LOQ. This triangle and triangle MOS. These two triangles we can take. So we can write in triangle LOQ and triangle MOS. Seventh point is LQ is equal to SM. That is from fifth point. So from 5 here LQ and SM are equal. Now again angle OQL, this angle, and what is this angle? OSM. What are these two angles? Here, this being a parallelogram, we know these two are parallels. And if you consider this SQ as transversal, these two angles become interior alternate angles. This and this also interior alternate angles. It will come like this, SR then PQ. If the transversal come like this angle and this angle, these two are interior alternate angles. Then this angle and this angle also interior alternate angles. So we can say that if two parallel lines are cut by a transversal, interior alternate angles are equal. So we can say that angle OQL, that is equal to angle OSM. So we can write 8th point as angle OQL is equal to angle OSM. What is the reason here? That is here PQ is parallel to SR, and also can say that interior alternate angles. So two conditions satisfied, that is two sides are equal, two angles are equal. Now one more side or angle we have to get as equal. Now what about these two angles LOQ and MOS, this angle and this angle? These two are straight lines, they intersect at a point. Then these two angles are vertically opposite angles. In that case vertically opposite angles are equal. So the 9th point, angle LOQ is equal to angle MOS. Reason, vertically opposite angles. Now 10th point. So here we got one side and two angles. So these two angles and this one side are equal in these two triangles. So we can say that their triangles LOQ and triangle MOS are congruent to each other by AAS test. So we can write therefore triangle LOQ is congruent to triangle MOS by AAS test. So as these two triangles are congruent, we can easily say that their corresponding angles and sides are also congruent. So this OL and OM, these two are corresponding sides of these two triangles. Again OS and OQ, these also corresponding sides of congruent triangles. So we can say that OL is equal to OM and OQ is equal to OS by CPC TC. Therefore OL is equal to OM and OQ is equal to OS. For these two, reason is CPC TC. So satisfied those two conditions. What is that meaning? This LM and QS bisect each other. So we can write therefore LM and QS bisect each other. Hence proved. 14th question is, in the following figure ABC is an equilateral triangle. All sides are equal and all angles are equal in the triangle ABC, in which QP is parallel to AC. These two are parallel to each other. Side AC is produced up to the point R. So that CR, this much length, that is equal to BP. What do you have to prove? We have to prove that QR bisects PC. That is, we have to prove that this PM is equal to MC. Here this triangle ABC is given as equilateral triangle. So we can write first point as these angles are equal and each will be 60 degrees. So we can write angle A is equal to angle B is equal to angle C. What is the reason? Triangle ABC is equilateral triangle. Second point, triangle BQP. We can write in triangle BQP. Then third point, these three angles are 60 degrees. So we can write angle B is equal to 60 degree. What is the reason? Triangle ABC is equilateral triangle. Fourth point, angle A. What is that angle? BQP. That is, this angle will be equal to this angle. How? We are given that PQ and AC as parallel lines. Then if you consider this AB as transversal, like this is AB, then these two are parallel lines, AC and PQ. Then this angle and this angle. What about these two angles? These angles are corresponding angles. What about these two angles? These angles are also corresponding angles when two parallel lines are cut by a transversal. Those corresponding angles will be equal. This angle and this angle will be equal. This angle and this angle will be equal. So this angle A, that also equal to angle BQP, that is equal to 60 degree. This is 60 degree, so this also will be 60 degree. Reason is corresponding angles. QP is parallel to AC and this AB is transversal. Therefore, angle BPQ. What is BPQ? BPQ. This angle is 60 degree. This angle is already 60 degree. Then what about this BPQ? Sum of the angles of the triangle is 180 degree. Angle sum property. So angle BPQ is 180 degree minus sum of these two angles. So we can write 180 degree minus sum of those two angles means 60 plus 60, that is 120 degree. So this is also 60 degree. That means this angle 60 degree, this angle 60 degree, this angle 60 degree. That means triangle BPQ is equilateral triangle as all these angles are 60 degree. So we can write sixth point is, therefore triangle BPQ is equilateral triangle. Now what is the meaning that this is equilateral triangle? All these sides are also equal. That is, BP is equal to PQ is equal to QB. So we can write as seventh point, this implies BP is equal to PQ is equal to QB. What is the reason? Triangle BPQ equilateral triangle. Now the eighth point, we are given that this BP is equal to CR. So we can write that BP is equal to CR. Now the ninth point, so this BP is equal to PQ, that is equal to QB. Now that is equal to CR. So what we can say, this PQ is the same as CR. That is PQ is equal to CR. This is given and this is from 7 and 8. So we got PQ as equal to CR. These two lengths is equal. Now let us take these two triangles PQM and MCR. So we can write 10th point as in triangle PQM and MCR. Now the 11th point, there we know PQ is equal to CR from 9. Now what about these two angles PQM and MRC? If you consider this AC and QP as parallels and QR as transversal, then what about these two angles? These two angles are interior alternate angles and are equal. So we can write as 12th point, angle PQM that is equal to angle MRC. Reason is interior alternate angles. Here this Q P which is parallel to AC also. Now the 13th point. Now what about these two angles PMQ and CMR? Here these QR and BC are straight lines and they intersect at this point M. So these two angles are vertically opposite angles and they are equal. So we can write angle PMQ is equal to angle CMR. Reason is vertically opposite angles. Now the 14th. Now what is this? In triangle PQM and MCR, one side in each triangle equal, then two angles in those two triangles equal. So we can say that those two triangles PQM and MCR are congruent to each other by AAS test. So we can write therefore triangle PQM is congruent to triangle MCR by AAS test. So these two triangles are congruent means all their corresponding sides and angles are also congruent. So this PM of this triangle PQM and MC of this triangle MCR will be equal as they are corresponding sides. So we can say that PM is equal to MC by CPC TC. So we can write therefore PM is equal to MC. Reason is CPC TC. So in this figure we can see that this Q bisects PC at the point M because we got PM as MC. So we can write therefore QR bisects PC. Thus we have proved.